It's showtime! Good evening. Welcome to Rubber Duck Engineering. Tonight we are going to be talking about compilers and my continuing compiler curiosity.
Is that alliteration? Continuing compiler curiosity. I love it.
Yes, I have my 8th grade English. The 8th grade English is strong with this one. But yes, we're going to continue. We're going to look at another language where we are potentially going to write another compiler. Last couple of shows ago, we were doing an Ethereum VM, which doesn't have a compiler. It just has an interpreter for the bytecode, right? So here we're going to go all the way to the source code. So stay tuned. Hi, Adam.
Hi, Eric. How are you?
I'm great. You can tell by my 5 o'clock shadow that I'm on vacation. So it's good times.
I don't even shave when I'm not on vacation, so I'm going for like the rugged individualist look.
There you go. It's good. Yeah, no, things are okay. I spent a bunch of time out of my house futzing with things today, which was a little bit of a drag. But I also spent some time sitting at the Visual Studio Code session, banging away at some Rust, which is always a pleasure.
That sounds cool. Yeah, we took the family to visit my parents, so the kids' grandparents, and they have a park nearby their house, so we went and explored the park and that kind of thing. It was good times.
Nice, good times. So without further ado, shall we head to the code machine? Or I guess we talk more about what we're doing.
Yeah, do you want to give some context? So what is this language that we're going to be writing a compiler for?
So the language we're going to be writing a compiler for is called Wren, which I'm sure never heard of, or most of the audience has never heard of.
W-R-E-N?
W-R-E-N, like the bird.
Cool.
So we should actually start back, like how we got here. So I enjoyed the Ethereum interpreter project so much that I actually did a whole bunch of hacking on it since we last showed it on the show. And so we actually talked about doing that for a show, and maybe we'll do it for a future show, or you can just go read the code. It's at github/rubberduckeng. But I did a whole bunch of hacking. But that code kind of dead ends. Like there's already a high quality Rust interpreter for EVM. There's already many implementations. And so like, I'm never going to take that to be amazing. And so I was looking for another like smallish project that was in that vein to hack on. And as I alluded to in the intro, moving up from a bytecode interpreter to a compiler, and a lexer, and a parser sounded like fun. So I looked at TI script. No, what's it called?
For like the TI calculators? Like
the calculators.
Oh, man.
I looked at doing an emulator for their little, I don't know if it's ARM or whatever, but their little instruction set. I looked at doing a compiler or like an interpreter for their interpreted language thing. But it's a little crazy, or it has a little bit of the characteristic of the web of being like both super low level and super high level, and also super focused on graphing calculators.
That was the application that it was designed for.
It turns out, like after I left the TI ecosystem, after my days of high school, they actually made it officially possible for you to compile for the things.
I remember, like in school, people had these incredibly sophisticated programs that they would run. They would run Tetris and like do all kinds of crazy things on these calculators.
Oh yeah, I wrote chess, like that little chess game for my TI in the scripting language, not in the little compile to the AOT. I'm sure I have it on a backup drive somewhere. All typed in, in between math classes or whatever, on the keyboard. So I looked at that for a while. That wasn't going anywhere. I mean, I could have done that, but I backed off from that one. And then I was looking at other like small languages. I looked at Lua. I decided Lua is a little.
Lua is interesting.
It's an interesting language.
It's very, very, very popular. Like I think it's embedded in tons of game engines, but I think as a programming language, it's a little questionable.
Yeah, it's based on some dated patterns, like for example, one-based arrays, which are like a Pascal thing, of many, many years ago. I think it was Pascal. It's the last major language to have that. Mm-hmm. Anyways, and so
I think Pascal relented, by the way. I think in modern versions of Pascal, like Object Pascal, I think they went to zero-base. But
I know that in Excel is still a one-based index, which Google Sheets has inherited. So then I went looking for other simple languages, looking for languages like what's a modern Lua? And Wren, it turns out, is the modern Lua. It's actually used by a game engine. Despite having over 100 contributors to the repository, it doesn't seem like it's gotten a ton of traction in the industry yet. But
pull up the page and let us take a look
yeah.
at it. Yeah, so I actually had encountered Lua before, Wren before. So I went on a very similar journey where I was looking for a very embeddable scripting language for a tool I was building, and I also didn't quite want to use Lua. We didn't end up using Wren. Don't recall we actually ended up using, but it has a sort of same flavor of being very, very compact, very simple language, very easily embeddable.
Sorry, I just have to press all the buttons. No.
Shuffle all the screens.
Shuffle all the screens.
I think in the interest of full disclosure, we should let you know that the person who invented the language is actually a friend of ours.
So I didn't actually know that when I found it. And then I was like reading the code and I was like, Robert? And I was like, oh, that's Bob.
It's Bob, yes.
And yes, it turns out that I do know Bob. And this helped me understand that Bob was even more fantastic than I knew. Anyway, so let's see, Wren. Not the bird. Sure. Wren language. Wren.io. Think Smalltalk in Lua-sized package with a dash of Erlang whipped up in a familiar modern syntax. So I will say that
that's a great marketing presentation. Like, this is actually really important for open source projects. Explain what you're doing in one sentence.
I haven't gotten quite far enough to know how much I love or hate like all the detailed language choices, but on the surface, it seems to really like push my buttons, like in a good way. So they have this fiber concept, which I think are like basically isolates or threads. It's a garbage collected language, which I have mixed feelings about. And it looks like it doesn't have semicolons, which I didn't actually know yet. I hadn't gotten that far.
You hadn't got that far in your parser to actually parse a semicolon.
It's super heavy on the classes. I was learning as I was looking to see how it does addition, that it has operator overloading, which I did not expect. And again, it leans into the classesness, so it's not like a free print function. It's on the system module. The core library for it, so we could actually, here it's telling you, Wren is small, 4,000 semicolons. I don't know if this is actually true. It's a significant amount of code, probably 4,000 semicolons, but it's skimming the whole thing in an afternoon. Yeah, I've done that. And it was about an afternoon. It's small but not dense. It is, and it's so lovingly written in C, which is a problem.
This is one that impressed me actually when I looked at the project. So I went when I do a little implementation. I was like, wow, this is really like a very finely crafted project.
Oh yeah,
I mean, that Bob has spent a ton of, and I'm sure the other contributors have like spent time like making this a really nice project.
Well, if you look at the GitHub, actually, I don't think Bob is actually active on the project anymore. I don't know how to. Yeah, here. If we go 21, so 31 people listed here. But if you look at insights, contributors, there are, I think, over 100. Yeah, there's 100 contributors total. And Bob hasn't really worked on it in, I don't know, a year and a half, 2 years, which is fine.
It's like Ruby has picked up on it.
Yeah, Ruby has totally taken it. And I think Ruby is the person who's involved in one of the game engines that's shipping with Wren. Anyways, where I lost my train of thought where I was going here. Yeah, Wren is concurrent, lightweight fibers, class-based, super class-based. Oh, yeah, so like we could look at the code, which may be sort of the next good step. So what did I do? So I created a repository, which I haven't marked public, but I can do that right after the show. And all it has right now is this one main.rust, and I don't think we should start there. Where I actually think we should start is the original Wren. So I have it as a submodule in Git, So it's just easy for us. It's the same MIT license and all that.
So this Wren C is a clone of that GitHub repository we were just looking at.
Yeah, I pulled it in as a submodule. So yes, pulled it in as a clone. But you clone the Wren Rust and it pulls in Wren C. And the reason why I did that actually is because of test. So Bob and friends, Bob and his merry band of mischief makers have a relatively extensive test suite. Where is it? So like language, like these are the ones that you want as you like get this going. I don't know if they have a math one, but so what about logical operator and.
Oh, okay.
So I haven't run the original test suite, but I don't actually know if it does this expectation checking.
Oh, I see.
I haven't found the code that does that. It looks like it does, and again, things that I know from having worked with Bob, like Bob has worked on test suites for his day job, so I suspect this is wired up, but I haven't found it yet in the C code. But it would be trivial to wire up in someone wanting to implement another copy of this language, right? You just hijack the system print. Sorry, go ahead.
Yeah, another possibility is, it says it also relies on system print returning its argument, which makes it sound like that this is going to wire into some automated system.
Yeah, I just hadn't found that code yet. Like maybe it's right here. And because you can, so one of the interesting things with both Wren and Lua, and I haven't compared their APIs, but I suspect they're relatively similar, is that they're entirely designed around embeddability. So like, for example, the REPL for Wren is not even in this repository. This repository is all about building, Wren.so or whatever.
I see, and the REPL just embeds Wren in sort of a simple way to make a REPL.
Yeah, and so they have, I actually don't know if it's a REPL, but there's like a CLI program for Wren that, again, I haven't built or played. I've just been reading the code because, as you noted, it's so lovingly common. It's just beautiful code for being C code. But so like here, this is just embedding the VM in this, right? So they embed. Oh, now I'm going to be a fool, but I swear they did this. It's like here they call Wren.
Oh, it is API test. Interesting. I wonder what that does.
Well, I think that's this thing.
Oh, I see.
Right. So this is the official API. Wren init configuration. Tell me how to resolve modules. Tell me how to load them. Tell me how to write.
Oh, is the write function where system print comes out?
Presumably.
I see.
Right. So, but VM write, I believe, actually just writes to the. So if I look at test.c, I think this has. Anyways, we're a little off in the weeds here, but yeah.
So
sorry, go ahead.
I was just going to read what it said. It just calls through to the C printf. Yeah.
So I have to figure out exactly because it's not clear to me that it actually uses all those test things, but that would be fun to wire up, for example. And that's a goal. I think I'm still a few days away from that. And when we get to the code that I've written, this will be more clear. But the core problem that I'm having is that, and as we look through Bob's code, again, Bob and his merry band's code, it's written in a very specific style that's C style. So like, for example, maybe we should just get to it. So if we look here at the source, the VM, so the two most important files from my perspective are Wren compiler and Wren VM. So the VM handles all the opcodes. It's not like Ethereum. So Ethereum compiles everything down to a bytecode.
Mm-hmm.
Wren compiles functions down to a bytecode, and otherwise has a tree of modules and functions that it passes along. So it doesn't have like a stable bytecode that it writes out to a file. It just builds a data structure and then sends it over. So the bytecode, I think, is for simplicity and speed, but is not like a full-blown API for that.
I see. So sometimes you end up walking the module tree in actual code, and sometimes you end up working with the bytecode.
I think you're almost always executing the bytecode. The module tree, you'll do lookups through it.
I see.
So I think it's because it's not forced to go through a file. And again, maybe it's an advantage, like a speed advantage, because it's not forced to go through a file. yeah, it never fully flattens. They keep some of the parser data structure and then they pass them over to the runtime as opposed to going through a file and making both sides build them.
That makes sense.
So
do you want to show us a little bit about the parser?
Yeah, so this side is where I've really spent all my time. And it, again, lovingly commented. It'll tell you, yeah, written at the bottom of our tokenizer comes first, parsing generate minimizes the explicit forward declaration. So this is like, hey, I'm writing C code, so I have to care about this stuff. Because in C, you have to forward declare all your functions.
So just to orient us, like how many lines is this file? I just noticed the scroll bar was tiny. Okay, so it was like a 4,000 line file.
4,000 lines for just the parser. So this is where I wonder about the 4,000 semicolons, but
okay.
The parser compiler, right? So it starts with a tokenizer. And this is a lazy tokenizer. One of the things that's a little weird is that it takes a UTF-8 char star, and then basically assumes the entire language is written in ASCII. Only in very few sections, like when you're in a string literal, does it say like, maybe there could be UTF-8 here. So that's a little sketchy, but it seems to work just fine. Again, you can do this sort of thing when it's an embeddable language, right? When you're not running like random code off the internet, which is what you and I spent so many years doing. These are some basic structs. Again, in C, this is how you do it. You type def the struct, and then you put the actual name of the thing at the end. So this is the parser struct. This is a local variable. I think there's a compiler struct here. Oh, here's the token struct. So there's a separate type. And then this value is a union. Anyways, if we keep going down, we'll get to the actual. So here's the compiler struct. Scope. There's a lot of complexity here. But if you get down, you'll get to that's the init. Here we go. Here's keywords.
And
what token?
Each one of them gets a separate token type. Makes sense.
Which I think if you did this in the Rust version, you probably wouldn't do that. You would just have a keyword token, and it would, bear the string along with it. Maybe not. I don't know. So one of the things you'll start to notice is the way that you make tokens. Like you don't alloc one.
I see. It doesn't return to you. Where does it put the token?
It changes the next token
it mutates
on the parser itself.
Parser. Oh, interesting.
So there's basically no allocation during. That's right. This is.
I see. Next, current, and previous. Interesting.
So like when you're walking through, you will make these tokens, which basically is like, where did it start? Where did it end? And the line is like for debugging, basically, or for like, pretty printing. But the token is just a range on the source string. Like this was one of it makes a lot of sense. This is one of the difficulties we had back with the HTML parser, is like minimizing the number of copies. Well, Wren just doesn't copy.
What's interesting, that doesn't even return to you like a token struct. Like it has a slot for the token in the parser object itself.
That's correct.
Does that mean there's like okay, that's interesting.
This is actually one of the things I've been fighting with, is like, this is not Rusty at all.
So I think there's a little bit of context. So you're looking at implementing Wren in Rust.
Correct. Did I skip over that part?
You skipped over that part, I think. It's the air you've been breathing for a little while. And so you're looking at these patterns and trying to say, okay, if you want to build your own parser in Rust, how would you do it? And this pattern here is a very C-like pattern because it's very mutation heavy. And so I guess you're asking yourself the question of like, what does this look like in Rust? I'm putting words in your mouth. Is that?
No, that's all true. I mean, so I think some of this starts from my programming experience. I wrote a whole bunch of C, and then I wrote a whole bunch of C++ and a bunch of Objective-C along the way. And so and now coming to Rust is very much like, oh, why didn't I have this for 10 years of my career? And so I'm gravitating towards the language. I'm really enjoying.
Oh man, this is like 4 episodes ago you'd written a line of Rust, and now it's like the angel music is playing.
It's totally my thing right now. I don't fully grok it, but it's so at least on the surface, it's vastly superior to the decade plus of my life that I spent writing C++. And just when I look at crazy stuff like this, like, first of all, like, okay, let's do all this hard work, and then like we're gonna malloc and free, and then if we look at things like Wren value, all this stuff.
Yeah, the variant support in Rust is super nice. Like it gets really hairy to do this in C and in C++.
And there's just all sorts of wild and crazy stuff that you have to do. So like this is the buffer is like the vector class that Bob had to invent in a macro because he might want to have different types of buffers. Like this is all banana pants by like modern programming standards. And again, this is maybe my sense of C code is off because I haven't done a lot of C in a while, but if you want to read beautiful C, this is some beautiful C. It's just, I think there's a ceiling as to how beautiful you can make it.
You're just sort of missing the tools, right? Like I don't know. I mean, C++ gives you a lot more tools.
Anyway, so I think it's very interesting to think. It's also, again, the authors of this did such a good job of distilling it down to the interesting bits. Like, and maybe this is because it's not been used hugely in production, but so often software systems just end up, you like write the original thing, and then after it's been used for 5 years, it's like grown these giant warts that are like its adaptations to the real world that are the same size as the like original thing that you produced. And Wren doesn't have that. What'd you say?
Or larger. In many cases, the warts, like the original thing, is not even there anymore. Like,
anyways, so that's, and maybe it's a toy project, but anyways, it's beautiful code. I could imagine writing in Rust, and then different from the Ethereum thing, I could imagine that you could actually have this be useful to someone, right? Because a modern version of a modern Lua has a potential to be useful to the world, but who knows? It's just always nice to have that like off in the distance if I ever worked on this enough that it could be useful.
So do you want to show us what you've done so far?
Sure. So I have not done very much except struggled. It's not true. I've written and thrown away a lot of code. So I started by taking just like a Rust example parser and running that and hacking that up and playing with that a little bit. And then I took some Wren code and I like tried to translate that to Rust and then like hacked with that and decided that, and I threw that stuff away. And then I took like another example that Bob had actually written in a blog post about some Java, how to write just like a basic parser. And then I've been like adapting that. I've kind of, I think, gotten out of the like general idea of how this should be structured. I just haven't had the moment to sit down. But so
you found the shape.
I think I've found like the next level of shape, and then once I get that typed out, then I'll find the shape after that. But a lot of the struggling was to find the shape at all. Mm-hmm. So this is our friend Input Manager that we had before in the Ethereum stuff, or similar to it. So I think the shape where this is going to end up going, you need something to handle the decoding, basically. Taking the input iterator, input string, and like letting you pull characters one at a time and maybe peek into the future a little bit. So you need something to do that.
Okay. So this is before you get to being a token. This is just literally sucking in the input and maybe translating it from UTF-8 into like actual characters.
Yeah, and I think the main reason for that is maybe my unfamiliarity with the Rust string types. It's not obvious that Rust provides these like string iterators or in char iterators, but you can't peek with them. So I think you need something around that to like maybe like pull the next n characters and save them in a buffer for you. That can work.
You think the Rust string types are optimized to try to make you write correct Unicode, whereas what you're doing here is you're sort of a little bit below the Unicode level, because you want to actually work with the actual bytes of the input, and then you're going to produce Unicode as part of what you're doing.
Actually, I do want to work with the Unicode itself, and so maybe it's that I don't fully understand the Rust, but I also need to peek. I need to be able to look 2 characters ahead or a character ahead or something like that. And the Rust strings don't support that out of the box.
Mm-hmm. It's just a complicated operation in Unicode, right? Because if you're in UTF-8, that's some variable amount of input that then has to be combined in some way.
And so I think it's actually a very simple class. It's input manager or something like that. And it also has like a peek buffer basically, which is like when you push it forward, you need to remember that, oh, I've peeked these, and look out of the peek buffer instead of like pulling another one off the stack.
Mm-hmm. Yeah, you kind of want to be integrated with the UTF-8 decoder.
Exactly. And I think sorry, go ahead.
Yeah, because peeking is sort of like running the UTF-8 parser ahead, and then what you said is you want to sort of not redo that work.
And I seem to remember we had something, again, this is many years ago, something very much like this in the HTML world, because we kind of need to use the decoder, because you don't want to like pre-decode the entire thing.
Well, in the HTML world, it's complicated because you can get these entities that are operating at an even lower level of the syntax than the tokenization, because it's weird and messed up. But
anyway, so I need some sort of like input handler thing, some sort of decoder thing that knows a little bit about peeking. And then I need a tokenizer. One of the differences in Bob's world is that in the Wren world is that it pulls a token one at a time. So the other examples that I looked at tokenize the whole thing, and they would hand you a tokenized string. And so I actually did some work to like change those examples around to like work in a single next token. And so then the layer that you build then on top of the input manager is then the tokenizer that knows how to pull from this thing, that also knows how to peek just a little bit, and then also just knows how to give you one token at a time, also can peek a little bit if necessary.
So how does the next token function peek? You just call it ahead and then remember the token that it gave you?
Well, you wrap it just like you did the UTF-8 decoder.
Oh, I see. You have it like a token manager that's analogous to the input manager.
Yeah, you just and that's probably what the tokenizer is. That's really what Bob's code does, is that like you always tokenize like one token ahead or something like that. And so then you can look at it, because sometimes you have to ask like, well, is the next token really a colon? Or is the next token really a new line? Or is it end of file or something like that? It seems to be a common pattern that they ask. You'll see one of the weird things about Rust is that, and this again is me sort of getting to know the string class. I'm dealing with it as UTF-8, sorry, not UTF-8s, as U8s. And so you have to turn the string literals into byte literals instead in order to match them. And then on top of that, Bob has, or again, Wren, I should talk about the language rather than the person, but the language has this recursive descent compiler, which we should go look at an example, because it's actually a little funny to read, which I don't know that you exactly replicate in Rust. This is where I think the designs really have to differ. But like if we look at like this, so like expression, where is it? Or Wren compile, yeah, Wren compile. So this is the main compile function.
Byte owner marks, they're always there.
Yes. So you set up the parser, which is on the stack, because here we are in C. You set up the parser, you fill your token buffer, because remember, you're always decoding one ahead. You initialize your compiler, and this is where it starts to read weird to me. So from here on out, you're actually declaring the grammar, basically, of the language. So this line here is saying, things can have leading new lines, and that's okay. We ignore them.
So like this is like the ABNF transposed into code in some way. So like this would be like a white space star, or like
basically. And so like this doesn't return anything. It modifies the compiler to change, its internals in terms of like this thing could be creating modules or creating functions or whatever, and we'll get to those. This you can ignore. This is a special case for because this is like the API, right? So this is the like, hey, I'm passing you just 1 + 1. Can you evaluate it for me? That's not the common case here. This is like, I want to compile a whole file.
While you haven't got to the end of file token, you can have a definition.
Yep, that's the compiler. But you can ignore this part. This is a like invalid syntax, but this is like.
Okay. And what does definition function do?
Well, good question. Because definition is not just a definition, which threw me for a loop here. So you try and it's basically a like priority order of what could this be. We're expressing the grammar again, sort of funny, at least to my eyes, in code. And I don't think this is how you'd write it in Rust. Like, oh, maybe this is an attribute. Oh, I don't know what this is. Token.
The class token, probably the part of the keyword.
Oh, I see. Yes, this is the class keyword. Right.
You have a class definition.
Right. I don't know. I guess this maybe sets some flag. I don't know what disallow attributes does.
It gets mad if you have attributes.
Okay, and then we can do imports. And then if we didn't do anything that, okay, then maybe we'll look at. You could maybe be a statement. Okay, well, let's look what the statement is.
Were we already in the statement function?
No, we're in the definition function.
Oh, I see. Okay.
So, but. And again, this is maybe a little weird, and I think it's designed this way because some places you can only have statements, and some places and so this is saying basically allow anything, any kind of code you would normally do, including the definition and other things that are also allowed when definitions are allowed, such as statements.
This seems like a sort of recursive descent parser, but it has instead of returning the result up the recursion, it's somehow producing the result as a side effect on the compiler.
That's correct.
I see. When I've seen this done before, I've used the return path to basically, try to parse a statement. If so, then it returns a statement object that then you can then attach to your syntax tree in the appropriate way in this function.
Yep.
It's sort of funny that it produces everything by side effect.
And again, I don't think this is not Rusty, right? Because Rust has all this language support built in for.
Yeah, it totally wants to be functional. It wants to basically like do a big map reduce over your entire input and like never have you mutate any field anywhere.
Yeah. I should note that that Giphy asked a question about the Flutter's Navigator 2 API being complicated. There's definitely been discussion around that. I've personally used it. It is complicated. I think the goal with the first version of the Navigator 2 API was around functionality. Can you do all the things you want to do? And I know there's been further discussion about what sort of levels of sugar to put on it to make it as easy to use as the Navigator 1 API was. So anyways, to get back to the Rust, we... Can
you jump to statement? I'm just curious what statement.
Yeah, it's more of the same, right? So it's... so now here, these are like, oh, well, break is a statement, or continue is a statement, or for, if, or return.
So it looks like the language is designed so that you only need a couple tokens a look ahead, maybe only one token look ahead to figure out the kind of thing that you're dealing with. For some languages, that's not the case. For some languages, you have to go speculate for a while and try to parse a whole complicated thing before you know that, oh no, it wasn't that. Let me unwind and try something else.
Mm-hmm. There's also a statement here. I believe that's true. So here, and then you finally get to, which I think is the more common case, you finally get to an expression. And then you get to the actual parser. So which we could go into, and Bob actually has an article about this style of parser. Named a little funny. I don't think parse precedence is really the name, but this is the parser, and you give it the current precedence that you're parsing at. And your subtree can like go to higher precedences. I don't think it can ever go to lower precedences.
Yeah, so usually, like if you have a sort of normal expression, it can like require quite a bit of look ahead to figure out what's going on.
Yeah, I don't know. I don't know about.
What do you think of like mixing plus and multiply, right? You have to figure out like where to the
Well, that's what this parser thing does. But specifically, there's this pattern of parsing. Let's see, parser Bob. What's Bob's last name? Bob Nystrom. This thing. In his thing. There's a parser thing. Stuff with stuff parser. There's a nice blog post. Here we go. Prat parsers. So this thing talks about specifically, and there's a comment in the code that pointed me. This is how I got to this. Particularly about this design of a parser, where it seems to avoid some of this look-ahead problem.
Oh, interesting.
But this is this. Go ahead.
What's the like the summary or the general idea?
You end up with these. You end up with these like lookup tables. With these little subparsers. And so you look up based on token what parser to try, and then it basically recurses from there into other little subparsers via lookup tables. I don't know that I explained it super well. But this was the part that I sort of just had finished wiring up in Rust right before the show. And so that's what this is doing. Is sort of like this grammar rules is really it's looking at these little parser subfunctions. So if we looked at this rules, here again we're in C, which you apply some Rust to this, it could look a lot better. But these are the rules for the token left paren, which here again, because of C, we're doing this sort of like, well, the way we did dispatch is, well, we made the token left paren be 0. And so we're looking it up based on, it's not an actual enum, because I don't remember if C has enums or not. But so here is like, and this little macro helps you say, well, this function, put it in the prefix slot.
Oh, wow. Wow, this is cool. Wow.
Yeah, wow. Anyways, there's so much good here. I just think moving it forward 30, 40 years in programming technology could be a lot of fun.
So you said you just started wiring this up. Can we see the part? Like, what is?
So let's see this part. So I was attempting to write one of these. Yeah, we hadn't quite gotten to that. So here is an attempt at writing this function that we were just in.
Okay, so I see you take precedence as an argument again here. Okay. So
we consume the token, which is not actually implemented, it just returns junk. We try to grab our prefix parselet from the token, this is not quite the right design. Really, this should grab a similar function, a similar structure to what you saw before, where it has it all in one gob, as opposed to grabbing it each time differently off the token. But and then we recurse, or sorry, we call the prefix 1, which could end up recursing. And then while our precedence that we were passed in is less than the precedence of the next thing, the next token, we keep grabbing off tokens and calling our infix parselet. It's called infix, but it's really all the non-prefix parsers, which when you read Bob's blog post, it explains all this. They're basically, the parsers are divided into the prefix parsers and the everything else parsers. And this is the everything else little subparser.
And this is some sort of like left association that's happening here on line 200, where you pass in your current left and it gives you a new left.
Yes.
Okay, this seems a little sort of magical, but it's kind of interesting.
It is a little magical, and so this was like my next journey, which I was working on just before the show, was like getting this wired up. And again, translating it to Rust. I was translating it to Rust from Java. Because this blog post, which I can recommend, and I tweeted about this afternoon, from 2011, was Bob leads into it as like, I discovered this amazing thing. I have to tell the world about it. I actually wonder if because this parsing strategy reminds me of what we did in JavaScript core. But like, I didn't know anything. Like, I don't have a computer science background, really. I've like learned it all on the job or, on nights and weekends. And so I'd never taken a parser course or a compiler course.
I took the undergrad compiler course, but we didn't learn about Pratt parsers particularly. We just used a different technique that they seemed very structured and elegant. The technique that we learned in that class was just very brute force, just like, okay, go find the next thing, build the tree. Didn't work out, unwind, try again. Like,
yeah. So I find this stuff fascinating, but I feel like such a novice. Giffy also asks, any thoughts on rewriting the Flutter engine in Rust or Golang? Do you think there will be huge performance improvements or easy to maintain code for future Google engineers working in Flutter? I think that if we were writing the Flutter engine today, given your and my current biases, Adam, assuming we were also the ones doing it, we would have ended up in Rust, maybe.
It's a tough thing, language selection for a project, because there are a lot of factors that go into it. Like in the Flutter engine, like a major component is Skia. And so you have to think about how do you want to interface with Skia? Mm-hmm. In the early days of Flutter, I tried doing a version in Go, but I found that the interface with Skia was awkward enough that it wasn't worthwhile. And so it just ended up being easier to use C++. But I mean, a lot of factors. Like it's not sort of a cavalier question that you can kind of kick around. You have to like study it, and like it's something that's going to affect the project for a long period of time.
My sense is also that Rust is where there's a lot of momentum at the moment in the industry, but it's far from done. My understanding is that the Rust to C interop is good, but I haven't found conclusive evidence or proved myself that the C to Rust interop is great. And that could matter a lot. Like it would matter a lot for this project, for example, because Wren has a C API.
Right, you want to sort of match, like if you're going to build a new embeddable Wren thing, you want to match their API either identically or as close as possible.
Well, like one of the ways you could imagine this going is like you could piecemeal replace it with Rust. Again, this is me hacking for fun, not because like Wren is a big thing and needs a Rust implementation. So like if this never went anywhere, like that's fine too. I learned a bunch. But again, for something like Flutter, again, there's a lot of factors that go into language selection. I would not rewrite any of it today. Like you would rewrite with a purpose. Like what is the business reason, or like what is the thing that you get out at the end? And the pot of gold at the end of the Rust rainbow is good, but I don't think it's good enough to justify, throwing away whatever hundreds of thousands of C++ code that is.
So where do you want to dig in on this Wren project? Do you want to work on the this parse expression function? Is there another piece of it you want to dig into? I'm just thinking, what do you want to do for the balance of the show?
So I think getting a Pratt parser to work in Rust would be great.
Okay, that sounds like
it may actually be achievable.
It sounds interesting. Like that little snippet of code you looks sort of magical and interesting, and I'm interested in like how to actually make it do something.
Yeah. So what it's wired up to do right now. Oh, it looks like I do have some warnings. That's fine. These are all easy. But what it's wired up to do right now is to just handle 1 + 1. Right?
That sounds like a place to start.
Can we parse 1 + 1? We can tokenize it. So if I do this instead, cannot borrow is mutable. It's not declared as mutable. Oh, why is it? Well, I see. It's because I eat it in one of them and I don't in the other. All right, so I think that works. I'm just proving to you that this works, right? So if there we go.
All right, looks legit.
The 1 + 1 that I'm passing in is actually being ignored, but it's required because otherwise I'll yell at you. But whatever, details. So
the next step is to try to parse the expression.
So we have a working.
So what does the compile function do? I just want to just walk through it. So you eat the input manager, you make a parser out of it. Okay. You eat the tokens.
the parser doesn't do anything, right? This is not even hooked up to the lexer.
Okay.
This is real. Sorry, the lexer isn't a real thing. This is real code. That's next to it, yes. So we're supposed to ignore the new lines. And then this is the thing that we want to do.
Okay, I feel like we need to pass in something. What is the point of this loop? It seems like it just...
I don't think this loop does anything.
Okay, great. So the parser has the input, and then you ask it to parse an expression, and it gives you out the expression. So do we want to print the expression to see what we got, or?
Yes. In fact, what this really should just be is expression. Expression is empty. Like it hasn't.
Okay. I imagine you need a question mark after a parse expression. I imagine that thing could produce an error.
I assume that it produces errors, but yes. Yeah, fine. So expression you're going to see is empty. It like does not have anything in it.
All right, we can just toss the debug trait or whatever.
Okay. Should compile now. Okay, but this is not going to. It's just going to print an empty expression class when it goes.
That's fine.
But we can try running it. It's weird to me that Rust prints these warnings.
But it still runs.
Yeah.
Okay.
Like I have to figure out what the compile flag is to make it not do that. Because coming from a Dart world, I expect those to be like analyzer time things. And then when I actually run the thing, I don't need to see them a second time. Oh, okay, we're looping indefinitely because we just... I'm sure we're looping indefinitely because like the parser doesn't do anything. It doesn't actually ever read that input.
Oh, all right. Well, it's good that we have a place to start.
All right, so parse expression consume should take and return the current token. So I think that's what next token does. I think if we just do self.input.
Okay, we're going to have some like mutable borrows here.
Yeah, I'm sure it will. This is probably needs to be mute ourself. Expected token got result. That makes sense that you can. I'm sort of lazily passing around lexer because like eventually I need to change these error types. This match type should be mute. Okay, prefix part slip.
Oh, you probably want a question mark after consume.
Yeah.
Let's see. I had a connection to your editor, but it crapped out over here. So I'm going to try to reconnect.
You show a fuchsia circle. It seems very appropriate.
How did it? Well, okay. Let me attempt to solve that problem.
Maybe the Visual Studio Code. Actually, what it could be is that I think it may be like night out, and so my little night shift thing on Windows is kicked in. All right, so I suspect we still. So that's the prefix token, and if we want to look up the prefix parselet. So the prefix parselet is wrong. We need to match. Like this is not how they should be, but match on self token. Is there a way to fill in all of them? I saw something today that.
Oh, you want like the light bulb, the cool light bulb thing that the Flutter analyzer has.
There was some language today that I was reading about that does that. Oh, it's Xcode. Xcode and Swift do that now. Whenever you type a switch statement, it'll like blah, splat out, which makes total sense. All languages should do that. The Rust analyzer for Visual Studio Code, the official one, and then there's like this rogue fork that people are advocating that you should use the rogue fork instead, which I don't understand. I haven't gone and looked into the politics of that. but the official one is lacking all sorts of features like this. I'm sure that all possible. Yeah, can't you just splat them out for me?
Wait, I can. Boom. Did it.
Those are not them.
Was it not that?
Right?
They're not all the tokens?
Oh, I guess those are the tokens. Is that the right thing though? Yeah, okay, you're right. Those are, okay. Yeah, so these now need to return, cannot find op in the scope. Okay.
All right.
I kind of like that Rust makes you be explicit here. Exactly.
There are these things. Do you have these parselets written?
No, I don't.
Okay.
Well, that's where we go back to the blog post and see how they did them.
All right.
So we don't need a prefix operator parselet because I don't think we have any prefix operator parselets.
Okay.
Like, what does a prefix operator parselet do? I mean, I guess there's a prefix operator parselet. Go ahead.
From the C code we looked at, it looked like parenthesis was.
Well, we don't actually handle parentheses yet, so like we could even remove that.
I see.
I really was trying to build a thing that could just do 1 + 1.
All right.
So I could uncomment out and really just trying to get to 1 + 1.
Okay. So this is like optional. Not everything will have a prefix parselet. Is that correct?
Well, if we look at the C code, that was the case. But the C code, I don't think is exactly. So grammar rules.
Because like, what is like op in his? Or does I scroll down? What do these tokens translate to? Like, try to find like the op in his world. Like, what is it?
Oh, that's his ops are all split out.
So like plus is one of them or something?
It's like star, I think.
But there's plus.
Plus. Infix operator.
Okay, so let's return none here for these. I think these are all going to return none. Like, what does he have for number?
What are the ones that are prefix? Left paren? Left brace? I don't know what operator.
Bang and tilde. So these are things that looks like they come before. Like plus is infix. Like it goes like number plus thing, and prefix is like a bang which comes in the front. That makes sense.
Interesting that tokens. Like what's a token? I don't know what a number is in his world. I should know this. Like what does a number get parsed as?
Maybe a number, token number.
There you go. This is a prefix literal.
Okay, so number needs to be a literal.
And what does the literal code do? Emit constant. Okay. I see. So that's what this grammar is doing, is basically calling your emitters in the right order. That's the whole job of these parselets, is help you build bigger things, but also just get called in the right order.
I see. So it's somehow organizing your. So they're trying to do this. So
we're going to need an emit function to like.
So is this on parser then? Oh no, I see. So we're going to say parser.emit. I'm just trying to write literal here.
Yeah, let's do parser.emit. Tokens value, right?
I don't know what you have in mind. You want to type what you have in mind?
I think we could just put it here. So this thing. Oh, I see. You're doing it in the style. see, how do we know what?
That's in the token here.
Is it like token 0? Is that how I get the value?
We made another match function where we match on a token. And then we know that it's a num. We have our, what do you call it? But then you can say like constant.
Mm-hmm. And otherwise we throw or whatever. Feels like we're having too many layers of matching here.
We could have already figured out the number here.
Yeah.
Okay. Yeah, this is like an error, right? Like panic.
Mm-hmm. Well, and as I alluded to before, this splitting these prefix parselets on the token is the wrong thing, because really the token needs to return a separate object that has these things on it. But I think we should cheat towards working. Also, we're basically out of time for the show.
Okay. What is emit constant supposed to do? This is supposed to return an expression?
I think this should emit into the bytecode. So here's where we're faced with another decision of, are we following the C pattern? Right, so emit constant adds the constant and emits a short arg. Compile the code to load the constant.
I see.
I see. So this adds it into like constant map.
I see, and then adds a reference to it. Whereas when we looked at the Ethereum VM, all the constants were inline in the bytecode.
But again, remember the Ethereum VM
was very simple.
Had a stable bytecode intentionally.
Mm-hmm.
This does
Whereas
not.
here it just says, "Oh, you're going to push some constant. It's over here in my constant table. Go find it." Okay. I feel like by the end of the episode, we had just gotten to the point where like the wheels were hitting the runway. We're starting to make progress, but that's okay. Like I feel like I learned something interesting about the structure of Wren and a little bit about these Pratt parsers.
Yeah, I think. I mean, maybe I should say the interest for me here is just the learning part. Like this is all novel to me, and it's forcing me to learn a bunch of Rust, which I like. And I think one of the things, and maybe you and I will find some time either on screen or off to hack on this together. Like one of the things I'm missing is and you've alluded to this before, I don't have like a sage to guide me in Rust.
It's terrifying to be the Rust sage, because I'm only like 1 inch ahead of you in my Rust journey. But I think this is where having a rubber duck is helpful. Just to
yes, having someone to bounce Rust ideas off, because so much of my time is figuring out like where should this be structured in Rust, and that's why you have to write 3 versions and throw them away. Mm-hmm. So.
I feel like we went to the point with render trees where like we like had been around render trees so many times that we knew how to just like type them in, right? Which is I feel like where Bob is with parsers and VMs, right? And so like he's at that level, and so I feel a little bit like he's the sage on the mountain, and we're sort of like learning from the little pebbles that are falling down the mountain, like his pearls of wisdom.
Yeah, and I don't know that Bob knows. He must know more. Like, how would he write this in Dart? Like. Dart is a more modern language, not in the same direction as Rust. But I think it would look very different in Dart, which Bob obviously knows super well. So anyways, wonderful to see you as always. Do you have any pizza update for the fans, or maybe you already did that?
Oh, we had pizza tonight. It was big because it was with the grandparents too. So we got to see the grandparents' pizza technique, and
nice.
Yeah, it was good. It was good times.
We stumbled into a new taco recipe this last week. It was actually a burrito recipe that we found off the internet and made, but then the tortillas that I bought were too small.
So they became tacos?
Tacos instead. But I made it again tonight because it was so yummy. So it turns out, so I grew up in, in the middle of the country, away from these shining coasts with all their fancy organic food and all. Ate a lot of taco mix tacos growing up. And it turns out you can make your own taco mix very easily.
By mixing together the stuff in the mix.
By mixing together the like 3 ingredients that goes in a taco mix. So I have learned that. That is the thing that I have learned, other than Rust, in the last week, or one of them. So, anyways, wonderful to see you as always.
Yeah, it was great to see you, Eric. And I guess I'll see you next week.
Yeah, for our 52nd episode.
Whoa. Crazy town.
Anyways, have a good night.
See ya.